Namaste, welcome to this channel Chemistry Made Easy by Dr. Ashok Mulik. Today we will begin with a new topic, that is atomic structure. So this is also very important topic for the beginners in chemistry, specifically for the 11th standard or below the lower standards. Then we will see what are the points of interest in this topic. If you see the atomic structure, it is the concept, that is, it is the theory, or there are a number of theories proposed to explain the atomic structure, and these theories are giving their views in different manners. But out of these, the most advanced theory is based on quantum mechanics and wave mechanics. So these theories are being discussed here in stepwise manner. First of all, we will see what are the dates that are going to be discussed, or what are the points of interest in this topic. So first is historical development of atomic theory. So this will discuss what is the history about atomic structure. Second point is periodic table. Then third is discovery of subatomic particles and Bohr atom. Then the fourth is Bohr's theory of hydrogen atom. Fifth is quantum numbers and atomic wave functions. Then next is the above principle. Then periodic properties of atoms. So these points are to be discussed in this topic. But today we will discuss the first point of this theory, that is atomic structure. So this point is historical development of atomic theories. So as we have seen that the initiation that took place in the history shows that, or it dates back in the BC to about 460. The historical development dates back to about 460 BC to 370 BC, when the Democritus proposed his views on the atomic structure. Then later on, he was the Greek scientist who proposed the ideas or his views on the atomic structure. Then next is Epicurus in 341 BC to 270 BC, who also proposed their views, his views on this nature of this atom in the molecule. Later on, the recent development we can see, that is 1880, John Dalton first of all proposed his views on the atomic structure, and his views, or according to his views, he says that the ultimate structure of substance or element is the very fine particle called atom. The ultimate particle, or in other words we can say the ultimate particle of a homogeneous substance, is the atom. And it is, if we consider any, for example, if we consider the atoms of hydrogen, or if we say the hydrogen as a substance, if we say hydrogen as a substance, then it is in the gaseous state, and if we refine, or if we separate the finest particles from each other, and if we keep it doing till we get the ultimate fine particle of hydrogen. So this ultimate fine particle is called atom of the hydrogen. And he observed that the atomic masses of such and atomic volumes of such fine particles, like that is atoms, are identical in every part of the hydrogen. So if we consider one hydrogen atom, it has same atomic mass and volume that can be observed in any other hydrogen atom. Or in other words, we can say chlorine or any other substance like gold. If we consider, say, one atom of gold, it has same atomic mass and same atomic volume everywhere in the substance. So the atomic masses and volumes are studied by him, and he later on said that the combination of various substances are taking place in terms of or in the form of their atomic masses and atomic volumes. What is meant by this? If we take, say, one volume of hydrogen reacts with one volume of, say, chlorine, it gives one volume of HCl, like this. So actually it gives two volumes in the reaction. It gives two volumes of HCl. But initially, when he considered the first reaction, experimental reaction, it showed that his work showed that experimentally, when two volumes, say, two volumes of hydrogen, we will write here as a substance, hydrogen, because at that time the structure was not known to him. Two volumes of hydrogen combined with two volumes of oxygen. It gave also two volumes of water. He studied that when two volumes of hydrogen were combined with two volumes of oxygen, it produced two volumes of water. So it showed him, or he concluded from his experiment, that the same volume of two substances, when reacted together or combined together, produces same volume of the product. So he studied, or he carried out the study or investigations on the basis of volumes in case of gases like hydrogen and oxygen. But afterwards, after a few years, another scientist, that is Avogadro, showed that on the basis of Gay-Lussac, or using the data of Gay-Lussac, he said that equal volumes of any gas, equal volumes of various gases at equal temperatures and pressure gave the same volume of product. Means when he carried out the reaction, he showed that equal volumes of reacting gases give the same volume of product. So in terms of volume, so as we have discussed that 2 volumes of, we can say 2 liters of hydrogen and 2 liters of oxygen when combined together gave 2 liters of water. This was his concept. So his investigations was based on Avogadro's investigations were based on Gay-Lussac's concept, that is data. So after then in 1861 later on in 1861 another scientist Kekulé in 1861 Kekulé proposed 19 structures for acetic acid. 19 formulae proposed 19 formulae for acetic acid. Then in 1850s, Canizaro in 1850s Canizaro revived the arguments of Avogadro and said that everyone should use the same set of atomic weights. Means after Avogadro in 1850s, Canizaro said that everyone throughout the world should use the same set of atomic weights so that the results obtained are acceptable throughout the world. Then in 1869, another scientist, that is the Mendeleeve and Meyer, or we can say Mayer, Mendeleeve and Meyer. These are 2 scientists. They independently prepare their periodic table of elements. They independently prepare periodic table of elements, and it is observed that both the periodic tables, that is by Mendeleeve and Meyer, are nearly the same or about of same nature or in the same pattern. There may be some difference, but the overall structure is nearly the same. So with this we will stop here our today's discussion, and we will see the next point, that is the periodic table, in the next lecture. Till then, goodbye. See you next time. Please subscribe to this channel, share this channel, and or we can say link to your friends, and please press the like button and bell icon. So thank you very much. See you next time.